Hello, I am Andrew Lan, and in the next couple minutes, I'll walk you through our project on modeling learner engagement with behavioral data. Current approaches to learning analytics are focused mainly on providing feedback to the learners about their knowledge states based on their responses to assessment questions. Accounting for additional cognitive factors, and most importantly, learner engagement, has the potential to yield more effective learning analytics and feedback. However, measuring these factors has remained a difficult task. Recently, the emergence of online learning platforms such as Massive Online Open Courses or MOOCs have the capability to collect behavioral data that can provide some indicators of these factors. Existing approaches to measure learner engagement can be roughly divided into two categories: device-based and activity-based. Device-based approaches measure learner engagement using devices that are external to the learning platform, such as cameras to record facial expressions or eye-tracking devices to detect mind wandering while reading text documents. These approaches require a learning platform to integrate external devices and are very invasive. Activity-based approaches, on the other hand, measure engagement using heuristic features constructed from the learner's activity logs. These approaches employ heuristic definitions of engagement that are not necessarily guaranteed to correlate with learner performance. For this work, we propose a probabilistic model for inferring a learner's engagement level by treating it as a latent variable that drives the learner's performance and is in turn driven by the learner's behavior. We apply our framework to a dataset collected in the fall 2012 offering of the Princeton University course Networks, Friends, Money, and Bytes on Coursera. The data consists of clickstream actions generated as learners watch lecture videos and responses from learners answering in-video quiz questions. Our measure of learner engagement is solely given by clickstream data, which can be collected from entirely within the online learning platforms, and are also directly correlates with performance. We first summarized the raw learner clickstreamed actions into 9 different features. First of all, the fraction of time the learner spent on that video relative to its length, and then the fraction of the video that the learner completed, the fraction of the video that the learner played, the fraction of the video the learner stayed paused on the video, the number of times the learner paused the video, the number of times the learner skipped backwards, the number of times the learner skipped forward, and then the number of time average of the learner's playback rate throughout the video, and the standard deviation of the learner's playback rate. Using these behavior features, we then propose 2 probabilistic models, including a response model and a learning model. The response model relates the learner's responses to assessment questions to their latent concept knowledge states. The learning model characterizes the increase in learners' knowledge induced by watching videos. The learning gain is proportional to our notion of engagement, which is modeled as a function of the behavioral features. Using cross-validation, we found that our model achieves better performance in predicting unobserved learner responses to quiz questions over 2 existing state-of-the-art models, the sparse factor analysis model and an advanced version of the Bayesian knowledge tracing model. Moreover, we analyzed the correlation between each behavioral feature and engagement. All of the features, except for the number of fast-forwards, are positively correlated with the latent engagement level. The features that contribute most to high latent engagement levels are the number of pauses, the number of rewinds, and the average playback rate. Furthermore, we also visualize the evolution of learner engagement over time. We break down the learners into 3 different types according to their engagement patterns and plot their engagement level over time. The first type of learner finishes the course and then consistently exhibit high engagement levels throughout the duration. The second type also consistently exhibits high engagement levels but drops out of the course after up to 3 weeks. The third type of learner exhibits inconsistent engagement levels before an early dropout.